Now let's look at equations and graphs of lines. Slope of a line. We first need a way to measure the steepness of a line, or how quickly it rises or falls as we move from left to right. We define run to be the distance we move to the right, and rise to be the corresponding distance that the line rises or falls. The slope of a line is the ratio of rise to run. Figure 1 shows situations in which slope is important. Carpenters use the term pitch for the slope of a roof or a staircase. The term grade is used for the slope of a road. So here in the first example, we have the slope of a ramp. Notice that the ramp rises 1 foot for every 12 feet of run. Right? So that's going to be a slope of 1/12. Right? The rise to the run. A picture of our roof here. The roof rises 1 foot for every 3 feet of it runs. And notice that for a roof, right, we don't consider it positive or negative slope. We're just looking at the pitch of the roof. I could have also gone this way. And that would also be 3 feet. And the grade of a road. Notice that the road rises 8 feet for every 100 feet of horizontal distance of road. So that means the grade of the road, or the slope of the road, is 8 over 100. And we could also reduce that to 2 over 25. So if a line lies in a coordinate plane, then the run is the change in the x-coordinate, and the rise is the corresponding change in the y-coordinate between any 2 points on the line. This gives us the following definition of slope. Right? So we have, in our example there, we have the rise showing you the change in the y-coordinate. Right? So if we have if the line rises left to right, we have a positive rise, so this is a positive slope. If the line falls left to right, then we have a negative slope. And to find slope on the coordinate plane, we can use the following formula, which is in your notes. So the slope m of a non-vertical line that passes through the points A, x1, y1, and B, x2, y2, is the rise over the run, or the difference in the y-coordinates over the corresponding difference in the x-coordinates. Right, so slope of a vertical line is not defined because we have 0 in a denominator. That's why we call that kind of slope undefined. Sometimes it's called no slope, but to me no slope could be confused with 0 slope, which is what a horizontal line has. Right, so slope of a vertical line is undefined because we have 0 in a denominator. So let's find the slope of the line that passes through the points 2, 1, and 8, 5. Right? And you simply take the difference in the y-coordinates over the difference in the x-coordinates. It doesn't matter which point you use first, so long as you're consistent. Right? So that means that the slope of our line, right, I'm just going to go left to right. Right? So that would be 1 minus 5 over 2 minus 8. We could reduce that. 1 minus 5 is a negative 4. 2 minus 8 is a negative 6. And that would reduce to 2/3. And that's all there is to using the slope formula to find the slope of a line. Right, and I'm going to pause this tape, and then I'm going to have you find some slopes of lines. Thanks for watching.